Good afternoon again. Good morning. We looked at refraction, the bending of light when it goes from one medium like air into another medium like water last week during block number 2. We saw this bending, and we talked about this bending as being due to the fact that light travels at a different speed in air than it does in water. We also talked about because the air is less dense, optically speaking, than the water is, as far as the light is concerned, it's easier for the light to get through air. It goes faster in air than it does in water. Because of that difference, the light bends at this interface, the air-water interface. It bends toward the normal when it goes from a less dense to a more dense medium, and when it goes from a more dense, in this case water, into a less dense medium, air, it bends away from the normal. The more we increase the angle of incidence, you see the bending becomes more pronounced. And there's something that happens when it's traveling in the more dense medium that is really unique and cool. It's a phenomenon called total internal reflection. So for every more dense, less dense pair of materials, there's a critical angle, an exact angle where if the angle of incidence is larger than that critical angle, a phenomenon called total internal reflection occurs. And I'm going to come in from the side here, and I'm going to increase the angle of incidence, increase the angle of incidence, and then boom, there comes an angle above which no light is refracted into the air. It all gets what's called totally internally reflected. Now I happen to have a mirror at the bottom of the tank right here, and that's why it's reflecting at the bottom surface as well. But again, if the angle is not too large, some is reflected. You might see a little beam going back down, but a ton of it gets refracted into the air. But above that critical angle, greater than that critical angle's value, no light leaves the water, and it all gets totally internally reflected. One of the applications of total internal reflection is fiber optics. A lot of telephone conversations, a lot of data is sent through what's called optical fibers. They're actually pieces of glass, very, very thin pieces of glass. This is an in-flight magazine page that I tore out on a flight to Mexico. It's an AT&T ad for their fiber optic networks, and it just says "Esto es un beso." This is a kiss, but of course the hand is holding a bunch of optical fibers, and phone conversations can be digitized. Just when you speak on your cell phone, it's digital. Your voice is being electronically changed from a wave into a bunch of ones and zeros, data, and those can be sent through the glass optical fibers very efficiently compared to electrical signals going through copper wire, the old way that phone conversations used to be carried. It works on this total internal reflection concept. I hope you can see right here that once the light goes into this, now this is not really optical fiber, it's plastic, but it's a demonstration of exactly what's going on in optical fibers. As you can probably see, the light is bouncing off of the air plastic interface, and it doesn't escape the tube, so to speak, even though it's bent into a circle, and it goes around the corners. I wanted to show you that. The other thing that's kind of interesting about total internal reflection, and you can observe this the next time you're in a swimming pool, is if you're looking in the pool and you look up, you'll notice that you can actually see objects that you're looking almost straight up, but you're seeing like a tree that's way over here. Again, because of this bending of the light as it leaves the water and bending away from the normal. if you go down and you look down water, in other words, you look like here, you'll notice that there's a place in the water where you can no longer see out. And the water looks to you like it's a mirror, it's shiny. Well, that's because that light is being totally internally reflected, and what you're really reflected, and what you're really seeing is the bottom of the pool. But your brain has become accustomed to it, like when you see a reflection, it looks shiny to you like a mirror. Anyway, that's something you can check out in the next couple of days if you can get yourself in a swimming pool.